Safi City is a town in western Morocco on the Atlantic Ocean. It has a population of 308,508. It's no vast ocean filled with all kind of fishes and gorgeous green spaces, but unfortunately suffers from a high rate of pollution because of the widespread factories that causes harm to the nature and endanger the people in the town, especially the elderly ones. On top of that, there is just one hospital in the city that serves all the patient with few doctors. Thus, the rate of the elderly death increases year after year. Let's take case of Ali, an elder patient who suffers from diabetics and heart issues. One day, while he was shopping in the market, suddenly he had a heart attack. People called the ambulance to save him, but it was too late for him. He passed away. There was nothing to do for him, until SEHAAS came to existence.
SEHAAS is an e-health solution that aimed to enhance the medical care system and look after patients' health by collecting vital signs no matter their localization, either in the hospital or outside the hospital, where doctors can access those informations and track patients' state via internet. Missions: collect vital information about the patients. Pursue and observe patient in real time from anywhere and anytime. Make the move to save the life of a patient when he is in danger. Targets: patient benefit from omnipotent care and can view their own condition on their phones. Nurses can monitor the state of the local patients in the hospital. Doctors have the privilege to supervise local and external patients from anywhere, either from within or outside the hospital. Benefits: the hospital of Safi City can now treat a greater number of patients. Doctors and staff can manage and take charge of large groups of patients more than before. The analytic studies of the collected data will help the researchers to find causes and cures of some diseases. The rate of death will decrease. For example, Omar is another elder patient that suffers from the same diseases as Ali, but he is equipped now with a vest filled with sensors connected directly to his body. The other morning he was alone at his house. His temperature started to increase. His heart began to beat fastly. No one was there to call the ambulance or perform the first aid. But thanks to SEHAAS equipment and the sensors network, the doctors now can locate the whereabouts of the patient and send an ambulance to pick him up as quickly as possible. Also, doctors can supervise the real-time values of Omar's different vital signals. This will allow an early diagnostic and a time to prepare the room for the immediate surgery if necessary. SEHAAS objective doesn't stop here. SEHAAS can assist Omar and all patients who are already in the hospital in order to keep them supervised under a special care. At the hospital, nurses can monitor the state of Omar and all patients who are with him in the same room. They can do it all from their personal computers that are connected to the data center.
Omar is not the only patient who can benefit from SEHAAS services. There might be billions of patients around the world. Each one of them have his own sensor network. This should provide a very large scale of data. The traditional information systems can't handle the processing or the storage of this huge amount of data. Here we are talking about big data. SEHAAS is an implementation of big data in the e-health field. Let's explain now the general architecture. The hospital contains several rooms and each room contains patients which are supervised locally by nurses. The patients can be either inside or outside the hospital. A wireless sensor network in each room ensures patients' vital data collection and their storage in the local sync. The wireless sensor network consists of the collect of different biomedical and geolocation data of patients. The local server gathers data that comes from each room's sinks, then transmitted to the data center throughout the operator network. The operator network is formed by network infrastructures router, switch, DSU, CSU, DSLAM. The internal patients can access their own state or data from their phones. The doctors can access to service through internet and from anywhere through his phone, his PC or his touchpad. The cloud is a high scalable and performant SaaS architecture which provides big data management. Trust cluster discard any data which is marked as not compliant by the trust server. If not, the data is processed and stored in the clusters within the cloud. Services interfaces are given to patients, doctors and nurses. Collection of data service. To be more explicit, we collect data from both internal and external patients. If they're in an ambulance, they can be informed of the nearest hospital. The various intelligent objects gather the patient's data different the wireless sensors network. For the internal patient, data is the biomedical sensors captures. It is routed to the sink then forwarded to the local server before it is transmitted to the internet. For the external patient, data is biomedical and geolocation sensors captures. Data is sent then through an indoor network access like ADSL, 3G or 4G to the eHealth data center through internet. Each intelligent object collects data from any of its sensor and encapsulates it with the patient-specific informations. The code is secret value shared with data center. The patient ID field is the external patient's ID code. The bed ID identifies a bed in a hospital room. The date and time represents the moment of the capture. The type is the differences between the types of the sensors such as temperature and heartbeat. The values field represents the value of the capture. The room ID identifies each room in a hospital. LID field means location ID. It indicates either patient is inside or outside the hospital. The position is the external patient's localization. Here, in this console, we can see how data is transferred from the smart object to internet with the explained encapsulation. Access patient service. SEHAAS offers services to the internal and external patients so they can access to their medical state, and based on this state, they can have the adequate advices and recommendations using a mobile application on their phones or touchpad. The communication is established via 3G, 4G or Wi-Fi and forwarded through the operator network to the data center. First, the data is verified by the trust server. If the device isn't authenticated, no permission is allowed to process or access data. Otherwise, the request is forwarded to the application source, which is running on the real-time applications cluster. This is how the patient mobile application looks like. He should be authenticated first, then he can choose to view his health state or have a costume advice, medical monitoring and follow-up. The nurse's role is to supervise patients in a given room at the hospital. They do it through a supervisor interface. The central server routes patients' data of the hospital to the data center through an optical fiber by the operator network. The doctors can monitor and supervise the medical state and the health of all of the patient remotely using a web-based interface. The data is transmitted via secure VPN and through the operating network to the data center, which implements various technologies to ensure an efficient big data lifecycle in the eHealth system. The trust cluster enables the integrity of information and the quality of service. The others clusters are services which are running within the cloud, like real-time applications, web application and storage. Nurse application. Once the nurse is connected through WebSwing, which is web server that allows to run Swing applications inside the web browser, he must be authenticated if the login or the password are wrong. The application displays an authentication error and asks for another attempt. The nurse can display all the patient's informations, edit informations like the first name, the last name or the age. Once the modification is done on the nurse's desktop, we can see it in the database if we refresh it. Here we used an SQL server. If the patient is no more on this room, the nurse can delete him from the list of the room's patients. Doctor application. This is the doctor interface. He should be authenticated, otherwise he can't connect to the application. The website is a single-page application where the doctor can interact easily with multiple components on a page, like informations about SEHAAS and its motivations or services offered to him. Doctor can display all his patients or search through them. As a result, the rate of elderly death is reduced. Doctors and nurses are more efficient and can easily manage the load of number of patients. Elderly people remain alive long enough to see their children and grandchildren grow. Like Omar, who is now enjoying life with his grandchildren and family, thanks to SEHAAS solution.